last one was less than a decade ago. Before then, the most recent occurrence was in 1882. And the next time, it'll be 2117, when few, if any of us, will be alive to see it. Among the most rare and predictable celestial events, the sight of the planet Venus slowly trekking across the face of the sun has been witnessed by humans only 53 times since 2000 years BC. What about the heavens have these phenomena taught us? And what else might we discover about our place in the universe during these next 6+ hours? The Venus Transit 2012, next on NASA television.
Good morning, good afternoon, good night. It depends wherever you may be watching us around the world. This is NASA TV's coverage of 2012 Venus Transit. I'm NASA TV senior producer Al Feinberg. With me, Office of Communications colleague Dwayne Brown. And we've got some really cool stuff to talk about tonight.
That is right, Al. I am so happy to be here. And ladies and gentlemen, you are in for a treat. You are going to hear and see firsthand, not just here in Washington, D.C., but all over the world, something that won't happen again for another 105 years. Now, as Al said, I'm Dwayne Brown with the Office of Communications, but I have one of the coolest jobs in the world. I get to work with special people who next to me, and I'm going to introduce him, but the incredible scientists, engineers that do all the incredible science activities and are all right now looking at what you guys are going to see, the Venus Transit, all over the world. First things first, safety for the folks watching this program. Really, really listen carefully. It's been on the internet, it's been on TV and other things. Do not go outside and look at the sun without some protection. We've got these glasses, and there are other types of components, but safety first. Safety first. Always remember that. And go to your internet, and it'll give you some other ideas for that.
I tested this, by the way, yesterday.
And there worked.
Just a little orange dot. Very safe.
And again, if you don't have the glasses, tell your friends to come watch NASA TV and www.nasa.gov. We're going to bring you it live and in color, not just here from all over the world. And we understand that there's now some cloud weather on the East Coast, but that's okay. You may get lucky, but again, you'll see it here and live and in color. Now, you know, social media, for all you folks who tweet, Facebook and everything, join the conversation. And we have the best of the best working this night, and he is going to be busy. Jason Townsend, you ready for the night, man? I know it's going to be, you're going to have a lot of fun with us, right?
Yeah, we're going to have a lot of fun tonight. We're just having everybody follow along. If you guys are online and you're sharing updates and so on, make sure to be using the hashtag #VenusTransit. Also, make sure to follow along on @NASA on Twitter, and to make sure to follow us on NASA Facebook and Google+. So we'll be looking out for good images. We'll be sharing them along on social media. And if you're taking pictures, make sure to look us up on Flickr. If you go online, the group name is Venus Transit. And so add your photos as you take them and have a good transit. Remember to be safe out there, everybody. And we'll keep checking back with what's trending and everything else that's going on.
And a reminder, Jason will also be keeping an eye on the different NASA missions and the imagery that will be come up. We've got the Solar Dynamics Observatory. We've got Hubble Space Telescope. And what else?
Astronauts, International Space Station.
That's right.
You name it, we got it. But you know who we have sitting next to us now?
I know this guy.
Okay, so I think it's time to bring him on. Now, this gentleman is Jim Green, Dr. Jim Green, and he is the director of NASA's Planetary Science Division. He is the boss. He is numero uno, the man.
In the solar system.
Of the solar system. And so we're going to go right to him, because you're going to start out with Jim, and we're going to have other scientists, but we're starting off with the boss first. Dr. Green, welcome.
Thank you very much, Dwayne.
How are you feeling about this today?
This is a fantastic opportunity to talk about the fascinating planet called Venus. You know, Venus is our sister planet, and we've learned so much about this particular object. Venus is a gift, and it keeps on giving. One of the things that we've learned by Venus transit is how far away the Earth and the Sun are. And that one unit of measurement, called the astronomical unit, we use throughout the solar system. And it's really changed our perspective of how big the solar system is, how long it takes to go from planet A to planet B. And so it's one of those fundamental things. But that's just the start of what Venus has done for us. You know, Venus was first observed in a telescope by Galileo in 1610. And when he saw it over a period of time, it changed shape in the sense that as it got close to the Earth, it formed a crescent phase. And as it got on the other side of the Sun, it had that full phase. And in fact, it looked like very much going through phases of the Moon. Now, Galileo put all that information together and determined that Venus went around the Sun. And therefore, the Copernicus theory of the solar system was the correct one. And when he started promoting that, because he now had observations of the sun-centered solar system, it changed our culture, it started the modern science, and it changed religion. And we owe Venus that. Now here's a transit that we hope to see. As you look in the screen of the object between us and the Sun, that's Venus. That's how it will look. We only see that very rarely, and in fact, the next time that it will occur will be in 2117. Most of us, maybe all of us, won't be here by then. We'll see what happens from other types of science. But Venus is just such a beautiful transit that occurs, and I hope you'll all have an opportunity to see it. So let me turn it back to Dwayne.
Well, Jim, you know, what I want to say, I would be remiss without acknowledging our good friends who actually are, you know, they're down in Hawaii, the NASA Edge guys. And well, you guys have been seeing them, and you're going to see them throughout this Venus transit, but we want to send out a shout out to them. Also, don't forget about social media. You met Jason, and join the conversation, ladies and gentlemen. Jim, Venus transit. We won't see this again in 105 years. Why should we care? Not so much when we can go into the scientific thing, but you know, the millions of folks who are going to be watching this all over around. We're going to be showing some of those sites and visiting. Right. Why should the folks care about this?
Well, we care on many levels. You know, from a perspective of wanting to know more about our solar system, here's an occurrence like an eclipse that's very rare, and of course it attracts our natural interest in looking at these wandering objects and where they go. And in this case, Venus is going to cross in front of the Sun. So there's the wonder of the phenomena itself. The second thing is that fundamental transit that is occurring is also of scientific interest. We've got a number of experiments that are going on. We're going to be looking at Venus just as it starts its transit, and we see the light from the Sun going through the atmosphere. This is going to enable us to take a look at perhaps the temperature and the pressure at certain levels in the Venus atmosphere over most of the disk. Now, we've never done that before in this way, and this is a perfect opportunity for us to do this. Even Hubble will have an opportunity to make some transit observations. So the scientists are excited about it. I hope the public is excited about it. It's certainly an important astronomical phenomena. And historically, this has been so important in terms of understanding our place in the solar system. As I mentioned, a sun-centered solar system. Our yardstick, a cosmic yardstick, one astronomical unit. It started our measuring system in space. And 50 years ago, this year, we launched our first space probe to Venus. So it was a planetary object of extreme importance that changed everything for NASA planetary science and really created solar system exploration as we know it today.
And tell us again, Jim, we've talked a little bit about the significance. Historically speaking, this is something talk about Captain James Cook, for example, back in the, is it the 1760s, right?
Yes, indeed. In fact, these transits were gaining a lot of interest in Europe. And in fact, you couldn't always see it from Europe. Sometimes you had to travel to great distances. And a lot of these early countries actually funded expeditions. Several expeditions to Tahiti, for instance, like the Cook expedition, went down to observe the transit. And one of the reasons why they wanted to observe it is to look at the transit at two very distant locations on the Earth. And this would enable them, based on the timing of each of those observations and a little trigonometry, thanks to Sir Edmund Halley, to be able to calculate that 1 astronomical unit. So this was really the first time that countries were investing in science, in expeditions to be able to do really fabulous science and understand our solar system as we know it today.
Jim, we know you have to leave. You'll be back a little later.
That's good.
You've got an event, right?
He'll be back.
Yeah, I've got to go to an event.
And it has something to do with this transit of Venus, is that right? You're going up there? You're going to actually go out and observe and chat about it?
Yeah, so we're going to talk to a number of people that are on a roof.
Great.
Looking at it and enjoying that, and we're going to talk about the history. We're going to talk about the science. And we're going to talk about what transits also mean for other fields like astronomy and astrophysics. You know, we're using that same concept of transiting planets to find other solar systems around other stars in our galaxy. So it's a historic event on many levels.
I want to ask him, where can I get one of those buttons? What's that button say? I don't know if our audience can see that. That looks pretty cool.
Well, it is a great button, but you have to go out and observe the transit. It says, I observed the Venus transit. Of course, you'll have to wear it this way if you observe the 2004, and this way you can wear it when you observe the one tonight.
Okay.
Or this late today in the D.C. area.
Well, Jim, we want you to have a great time. We'll see you a little bit later. In the meantime, we have somebody else standing by at the Johnson Space Center in Houston, Mario Runco, who's going to be with us shortly and talk a little bit more about this Venus transit and what it means historically, scientifically, and talking about history again. We have a little message.
Yep, and before we run the intro there, again, stay with us, ladies and gentlemen. Join the conversation on social media, Twitter, Facebook. And this is the first stop. We're going to be going all over the world. Let's go to Houston.
All right. We are now on the eve of a second transit of a pair, after which there will be no other till the 21st century of our era has dawned upon the Earth and the June flowers are blooming in 2004. When the last transit season occurred, the intellectual world was awakening from the slumber of ages, and that wondrous scientific activity, which has led our present advanced knowledge, was just beginning. What will be the state of science when the next transit season arrives? God only knows.
Here at NASA headquarters in Washington, D.C. Al Feinberg, senior producer of NASA Television. My colleague, Dwayne Brown of the Office of Communications, Science Mission Director. And this historic event, not the next one, not for another 105 years.
I'll be around. Maybe? No, never mind.
Barring a miracle of science.
Well, I work for the Science Mission Director. We may have it. You never know.
You know the right people. We'd like to go now, and we've got people we're going to talk to all over the globe today. We're going to be talking to folks in Australia. Our NASA Edge colleagues will be at Mauna Kea in Hawaii. We've got hopefully we can hear from somebody in Fairbanks, Alaska, if he makes the call.
That would be pretty cool.
And some other folks too. But in the meantime, let's go to the Johnson Space Center, where standing by is former astronaut Mario Runco, who is considered to be one of the experts at regarding the Venus transit. Good afternoon. Good afternoon, sir. Welcome.
And thank you. Good afternoon to you. Thanks for having me.
Tell us what this means to you personally. This is a pretty exciting event.
Well, actually, for me, it's an exciting event that goes back of my interest in space and astronomy since I was a young boy. But more importantly, today is the involvement with the International Space Station and the observing of the transit by astronauts on board, particularly astronaut Don Pettit.
Now, we understand that Don we're during cruise sleep. So there's a possibility that we're not going to be able to see too many shots. Is that right? But Don's going to be getting up periodically and taking some pictures and shipping them back down to Earth. Is that right?
Well, that's correct. And Don, let me clarify the crew sleep part of that. Officially, it's during crew sleep, but I suspect this event to the crew, and particularly Don, is like Christmas Eve, and the presents are going to be under the tree, and you're not going to sleep very well. So Don is actually going to be getting up and taking pictures of the transit of Venus beginning shortly here within the hour. And he is going to be taking the pictures using an 800 millimeter lens with a high-end Nikon camera. Of course, he has the appropriate safety solar filter on the end of it and the prescribed sunglasses to do the filtering. He is, and it's a first for the International Space Station, going to remove an inner pane. It's a safety pane to protect the windows from being scratched and the like. They're actually called scratch panes, but those inner panes are not optical quality. So those are going to come off to allow us to get more detailed, sharper, clearer images of the transit. And as I understand it, as soon as Don is going to collect a battery of images, he will load them up for downlink, and we'll get those posted online as quickly as possible.
Well, sir, this is Dwayne Brown, and again, thanks for joining us. Let's bring it a little bit down to earth here. We've talked about all of the places all over the world that are going to be monitoring and observing. Can you tell us the scene down in Houston, Texas? Well, what's the folks looking at, and anything that really, are they excited down there as the whole world is? I'm quite sure, right?
Actually, very much so. It started off slowly, of course, as the transit got closer. The interest, of course, built over time, particularly once we found out that Don was going to be taking the images. Of course, that swept up most of the people here immediately at the Johnson Space Center, but in the wider community as well. And the historical perspective is quite interesting from my point of view, and I guess a variety of folks here, is that it pinpoints in time the technology we have today to observe the transit of Venus. You guys mentioned the Hubble Space Telescope, we have the SOHO satellite and others observing, and we have the International Space Station. Of course, we talked about James Cook, the English explorer that went to Tahiti to observe the transit of Venus. Like we are talking about him and previous observations, juxtaposed in time in 2012, people in the future will talk about what is now in orbit, the International Space Station, probably the personalities in Don Pettit and several of us, Dr. Green, et cetera. And then who knows, like you said, as in the future, what will hold in 2117 on the next transit as to what we will be using, what will be in orbit, what spacecraft we'll have. We may have even have people who have orbited Venus at that point in time.
This is Dwayne. Just a follow-up on that. Looking into the future and orbiting in Venus, exciting times for NASA with the recent success of SpaceX and things. And to put it in context, the synergy between science and human spaceflight. Describe that for us. I think the future is bright for both.
Absolutely, and I'll put that in a historical perspective, because years ago, folks used to be an aficionado, a fan of robotic missions or of exploration in that mode, and then there was the manned space program, and there were two separate camps. But I think today, nowadays, most people understand that the two are very synergistic. The robotics missions certainly can go farther afield a lot more quickly, because we don't have to worry about keeping people safe and alive for a two-way transit. Maybe one day they'll be one way. They'll just send them out and they will establish colonies and they won't return. But I think the real quest and what really makes the exploration exciting, that brings people in, is having people directly involved, and what the human brings to the table. For example, if we go to Mars, the aspect, and actually let me mention the Mars Science Laboratory is going to arrive there this summer. It's a new robotic probe that's about the size of a Volkswagen Beetle, the most capable exploration rover we've had to date. It is going to be there, but it is limited in its variety, and that's a limitation of our technology today and what it can do. It's very capable, more so than anything we've sent there in the past, but the real ingenuity, the thinking, the discovery, the creative aspect, to know what's important, to know what to look for beyond the programming, is where the human being comes in. And indeed, that happened in our lunar exploration when we brought back rocks from Apollo. There were certain ones that were noted to be different and picked up and brought back, and they taught us so much about the moon, the evolution of the solar system. And so I think it's really a win-win situation for both. We need the robotic probes, certainly to answer some of the preliminary scientific questions, but to solve the riddle, to find out if there's life, for example, to dig underneath the rock that can't be moved by the robot, you want the person there.
Well, Mario, thank you so much for joining us. We're going to be going to another guest in a few minutes, but we want to thank you very much, and we hope you enjoy this evening as much as we know we will. And please say hi to Don for us up in the station, and we'll look forward to seeing his imagery.
Thank you, sir.
Okay.
Thank you very much. Happy viewing.
Right. Thanks. Okay, Dwayne, this is going to be quite an evening.
Yeah, we just started, and there's more to come.
Yeah, absolutely. Right. We're going to go, I think Jason Townsend, our social media maven, has an image, is that right, Jason, that you have for us? Is that right?
I do. We've beginning to get some good images in here from the Solar Dynamics Observatory. We just retweeted Camilla SDO, for those of you who follow her on Twitter. We put her out, and there's an image that's from the 211 wavelength from SDO, and it's been put out on the @NASA account. So if you're not following along, follow us on Twitter. We're at @NASA. We're getting ready to post it up onto Facebook and everything. But it's a beautiful shot with Venus just beginning to pop into the field of view here and begin its transit across the sun. So stick with us. Remember to follow along. If you're out on social media talking about this, make sure to use #VenusTransit. That's the hashtag for tonight, and join the conversation. Hop online. Thanks, guys.
All right. Thanks, Jason. And we'll get those imagery up for you as soon as possible so you can see it right here with us as well. We are going to be going to the Goddard Space Flight Center, where we're going to be chatting with another expert to talk about this Venus transit and what this means. And perhaps we can find out from Dr. Jim Garvin exactly why this happens like every 105 years.
Yeah, and you know, when Jim, you know, we got a lot of Jims. We got Jim Garvin, just have Jim Green. It's a popular name, but these guys are the best of the best. And you know, at the Goddard Space Flight Center in Greenbelt, Maryland, they're home to the Hubble Space Telescope. They're home to the James Webb Space Telescope, the next generation, as some folks call Hubble 2.0. And this is why we're so excited, not only to be a part of this, but the incredible things on the horizon for the National Aeronautics and Space Administration. And the Goddard Space Flight Center is playing an extremely vital part in making that happen, Al. But this is about Venus, and I don't know. We're here. We're going to be going around the world. We got our main man, Jason, doing social media. Are we missing anything here? I mean,
well, I think we talked a little bit, and we can start showing perhaps a little bit of information about some of the other locales we'll be going to at some point. There you can see, guys, the folks at NASA Edge. We're going to be going to them at 6:03 Eastern, which is coming up in another, I guess, 13, 14 minutes. And they are going to get us into the ingress of Venus as it starts crossing the face of the sun. Now, some of the other locales. Let's go and show you. There they are. They're in Hawaii. There's the Hawaiian flag. Is that right? Wow. That is great. And here are some of the other locales. We've got the NASA Edge Hawaii, Mount Wilson Observatory in California, the Glenn Research Center in Cleveland, at Alice Springs, Northern Territory, Australia, which is right in the smack dab in the middle of the Down Under. And we've got folks from the Coca-Cola Space Science Center at Columbus State University in Georgia. They're there. They actually, Dwayne, they also have a team in Mongolia, I believe, will also be there. We're going to have a web stream coming from Norway. And this one is one of my most
I was looking at. I was waiting for you to. How do you pronounce that?
I believe it's Muchul, the United Kingdom. That's in Lancashire, Great Britain, and that is they're having a special web stream at the church, St. Michael's Church, where Jeremiah Horrocks was. He and his partner, I think it was Jeremiah Craven. Am I right? Who first observed the Venus transit. I think it was in 1631.
Yeah, well, we'll verify that. But
really,
yeah, we got
cool.
all kinds of years and dates flying around.
Real cool. So, and Fairbanks, Alaska will be in Fairbanks. The Indian Astronomical Observatory in Hanley, India. And we're going to have a feed from the European Space Agency, ESA. They're going to have some information coming down from the Venus transit satellite that they have that is doing a polar orbit of Venus. And that's coming through Svalbard, Norway, I believe. That's where their space station is. And interesting thing about Svalbard, which I don't know if you're aware of this, but
you're just a man of knowledge. Just keep it coming, man. I'm learning a lot.
You can find out a lot on the internet.
Maybe we should go to some of these places.
Well, yeah,
you think we can?
I'd love to do that actually. But Svalbard is the place where the world sends its seeds to be stored in the event of some catastrophe, some world famine, so that everything is protected. There's a deep vault in this mountain, and because it's so cold, it forms another layer of protection. And it's the Global Seed Center, Seed Storage Center. So, and it's quite interesting, but that's also there. And then, of course, we've got the International Space Station.
Well, I guess it's safe to say, and we've been saying this at the beginning of the program, ladies and gentlemen, this is a global watch for the Venus transit. And my colleague here, Al, that's some of the places that we hope to bring some of the live coverage there, but there are places and viewing areas all over the world. In fact, Al, it's my understanding that there are stadiums that are going to be hosting thousands and thousands of people just for the viewing. Sports stadiums.
Wow.
I think that is very, very, very cool. It is global. Follow the conversation on social media, all of you, Facebook, Twitter, YouTube. Watch it. I know you're out there. We got our main man, Jason Townsend. We're going to have fun, and this is just the beginning. Keep staying with us. Al, hopefully we can get outside and even see this, but if not, I'm happy, and I can't wait for our next guest.
Well, in a few minutes, we're going to be starting the ingress, 6:03 Eastern Time, and we'll be going to NASA Edge. And then maybe we can get outside because there's still some hours of light here, and hopefully there's no cloud cover. But now let's go over to our colleague, Dr. Jim Garvin, the chief scientist at the Goddard Space Flight Center, a great hockey fan as well. But Jim, tell us about tonight and why this is so exciting.
Well, hi, Al and Dwayne. It's great to be here. Tonight's really special because this is a very rare astronomical event. And what we can learn from it is really a dry run for how we can observe like planets or Earth-sized planets transit other suns. So while this is an event here and now, also a proving ground for how we can discover extrasolar planets and even start to tell whether they're more like Venus or more like Earth. So for all of us interested in the solar system, we can actually think beyond into the larger universe from this event.
Now, for those of you not in the know, in the past several years, I guess, through one of the NASA missions, Kepler, there have been identified at least, 700 planets outside of our solar system called exosolar planets, and using the same phenomenon, a transit in front of a planet or in front of a star, similar to what Venus is doing in front of our star, the sun. Isn't that right, Jim?
That's right. And in fact, that's why this is so important. We're now, from a space-age perspective, a spaceborne perspective, seeing what we're trying to understand around other stars. And in fact, trying to use Venus as a proving case to understand the difference between a big, hot, orange ball planet like Venus versus our pale blue dot Earth is one of the most important kind of things we can do. And as we look forward in exploring the universe, that's one of the things we want to be able to tell. The atmosphere of Venus is in a different state than that of our own planet, which of course is where we live and hospitable. So as important as this is right here in our solar system, it's also important as we look beyond. And it also reminds us, as we think about Venus on this historic date, how little we know of our sister planet. I mean, to me, that's one of the exciting things. We got to get there to understand this world.
Jim, this is Dwayne. Again, thanks for joining us. And, you know, and I told our audience at the top of the program, I have one of the coolest jobs working with incredible scientists as yourself. I'm going to divert a little bit because I know you're working on an incredible new strategy for Mars. And I know this is about Venus, but kind of put it in context about Mars, what's going on, and how perhaps Venus and Mars, I know you had mentioned Earth, how they may, well, how they certainly differ, but any similarities. But before you do that, tell us what's on the horizon for the new Mars planning program.
Well, first, Dwayne, what's most exciting in the near term for Mars is we're a month or two away from a historic landing of the first surface observatory of the class of in history called the Mars Science Lab. And I think the Mars Science Lab and that rover Curiosity, an investment in 10 years, 12 years of work by the Mars community, really puts into perspective. We've come out of the kindergarten age of exploring Mars into a much higher state. And the Mars Science Lab will be asking the kinds of questions that we ask even about places here on Earth, on another world, with a robotic laboratory, a robotic surface observatory. So as we plan the future of Mars, we're going to learn from the Mars Science Lab. And that's landing's coming up on August 5th and 6th here on Earth, another big solar system event in this year. And that landing will help us, and the science from that mission, help us to understand the kind of questions as we probe the world of Mars, compare it to Earth, the kind of questions that were left for the planet Venus. We've never done anything like the voyages of exploration we've done at Mars, as you know, Dwayne. The Mars exploration rovers, even going all the way back to the Viking mission, the Mariner 9, those missions at Mars have opened the Martian frontier. And now, as we watch this historic transit of Venus, we wonder about that Venus frontier. What could we find? I like to tell the kids, there's a pony out there, we just have to find it. But let me come back. Mars is in a very important state of changing knowledge. We know where we need to go. We know what we could possibly find. And so we're planning, a big team across the country, across the world, a workshop in Houston in about 2 weeks, in fact, to bring together those ideas. We're planning what that future could be, responding to what the Mars Science Lab will tell us, and we can't really foresee that until she makes those measurements, but also responding to what we've learned for the last decade of the Mars exploration program. How do we explore a potentially habitable world? How do we find those fingerprints, those clues? It's kind of like CSI does Mars, to what might be preservation of past records of life, if there was ever any. How would we find extant life if it ever were to exist on Mars? These tough questions are part of the planning horizon we have, guided by the strong recommendations from the National Academy of Sciences, which has given us, if you will, a blueprint for planetary exploration for the next decade from what they call a decadal survey. So for Mars, lots coming, Mars Science Lab and MAVEN, the next two missions. And after that, an open frontier of possibilities. Of course, central to them is finding a way to bring back materials from Mars to our Earth labs so we can basically generate science that will be a gift that keeps on giving. Those samples, like we have from the moon, the ones we need from Mars will be that kind of legacy. Now, what that does for us, though, Dwayne and Al, is bring us back to Venus. So why aren't we there on Venus? With this great program of exploring Mars, heading out to Pluto, going back to Jupiter, exploring Saturn, what's wrong with Venus, you might ask, particularly on this moment of the transit as it's about to begin. And the problem is Venus, as one president once said, is really hard. And to get to Venus and do the kind of things we want to do, the kind of things we're doing on Mars, takes new technology, creativity, new classes of instruments, because the environment there at the surface is just so inhospitable. It's unimaginably different than Earth and Mars. So here we sit as we're about to explore Mars in the major next step, and we think back at our sister planet Venus and say, well, someday we got to get back there.
Jim, question. With this Venus transit, obviously there are expectations, scientific expectations, about some of the things we might learn. Can you prioritize for us maybe the top 3 things that you would like to see us learn from this Venus transit of 2012?
Well, I think Al, there's at least 3, and let me give them to you in sort of no absolute priority order, because it all depends on the scientist making the observations, how important they are, and it's always hard to judge our kids, if you will. The first thing we're going to be doing is using the Solar Dynamics Observatory. We will be, for the first time, having a high-resolution spaceborne view of, in sort of movie mode, of what's going on as Venus occults the sun tonight for the 6 to 7 hours that it will last. And by timing precisely the information we collect from the various imaging systems and imaging spectrometers on SDO, we can better quantify exactly where things are in its instrument's fields of view. And that kind of geometric improvement will be extremely important for calibrating those instruments to make even better measurements of the sun as part of the SDO mission. Number 2, we are going to try a very novel new kind of experiment, again, a practice for things we might be able to do as we look to other suns and planets around them, by using the Hubble Space Telescope in what is a very challenging kind of observation, but a very exciting one, to observe the faint variations in the change in light as Venus crosses the sun, as reflected on the surface of the moon. Now, we've looked at the moon with Hubble as an object of exploration in 2005 and before, but this will be different. We'll be watching the moon to see the effects of the transit of Venus on the sun and try to see very, very faint, less than 1% changes in the reflectivity of the light on the moon from Venus on the sun, to understand some of the subtleties of the atmospheric chemistry of Venus. And Venus' atmosphere is like a giant chemistry lab of planetary evolution. It's so big, it's changed, we think, dramatically since the time the planet was born over 4.5 billion years ago. So it's a record book, and we want to measure its chemistry using every inventive technique we can. So the Hubble Experiment is another one. Other satellites, RESI, and some of the satellites that are from ESA and Japan, will be making independent observations, all coordinated as a giant science network or family across the world. And so those together will try to peel back, try to extract, if you will, subtleties of the makeup of that atmosphere of Venus, which we just haven't gotten that far probing. We had limited success with our measurements thus far here in the United States, understanding this massive atmosphere of our nearest neighbor planet.
Jim, this is Dwayne. It's always a pleasure to have you a part of the shows like this. I've known you for a long time. Thank you for your time, and enjoy this evening. And we'll see you at Mars, and enjoy the show.
Thanks, Jim.
Thanks, Dwayne. Al, always a pleasure.
Take care.
Folks,
enjoy tonight.
Enjoy, yes. And I know I'm enjoying it. So, ladies and gentlemen, if you've just joined us, welcome to NASA Television here at NASA headquarters, where we're taking you on a ride of a lifetime. And our social media audience, Twitter, Facebook, YouTube. Jason Townsend, Twitter, join the conversation. It's all around the world. We're just beginning. And now, Al, I think it's time to really go to the place where a lot of cool stuff is happening.
Stuff is happening. We're going to go to Mauna Kea, Hawaii, and our colleagues from NASA Edge, and they're going to be taking us through Ingress, the beginning of the Venus Transit 2012. Guys?